counting molecules by the gram. So for elements, the molar mass is the mass of 1 mole of atoms of that element. But compounds have more atoms in them. And so the molar mass is the mass of 1 mole of molecules or formula units of that compound, which relates to that little bit of chapter 5 we talked about first. We can find out the mass of the molecule or the formula unit. So it's important to recognize that ionic compounds do not contain individual molecules. They contain ions just in a regular repeating order. Plus, minus, plus, minus, plus, minus, plus, minus. And so you could really think of however big that piece of ionic substance is, essentially it's one giant molecule. We can't have molecules of the same compound that are all different sizes. It's not useful for calculations. And so we look at the formula unit, the lowest ratio of the ions, when we talk about stuff like that. But for the molecular compounds, we're doing molecules. So we can convert between the mass of a compound and the moles of a compound. And then we can, I lost where this was going. We convert between the mass of a compound and moles of the compound, then we calculate the number of molecules or formula units from moles. Whatever. So the molar mass is numerically equal to the formula mass. The formula mass was the mass of 1 formula unit or 1 molecule. The molar mass is the mass of a mole of those things. And so they're calculated in the same way. The only difference is that the unit is different. A molar mass gives us grams, and that's what's useful. So calculate the formula mass of calcium nitrate. Formula mass is the mass of the formula. That's going to be in atomic mass units. So we look at this formula and we identify how many atoms of each element are in there. There's 1 calcium. 1 calcium, and it weighs 40.08 atomic mass units. How many nitrogens are there? There's 2, right? Because we have this group that's shrink-wrapped, and there's 1 nitrogen in there, and there's 2 of those groups. So we have 2 nitrogens, and they each weigh 14.01 atomic mass units. And how many oxygens are there? There's 3 times 2, which is 6. 6 oxygens, and each of those is 16.00 atomic mass units. So we add all these things up. 40.08 plus 2 times 14.01 plus 6 times 16, and we get 164.1 atomic mass units. That's the formula mass. That's the mass of 1 unit, the smallest unit of that ionic compound. What's the mass of 1 mole? 164.1 grams. That is equal to 1 mole. Avogadro's number of formula units of that compound. Any questions? So calculate the mass in grams of 2.48 moles of phosphorus pentachloride. Oh no, they gave us the name and not the formula. We have to practice our nomenclature. Phosphorus pentachloride. What kind of a compound is that? Ionic, molecular, or acid? Please don't say acid. Molecular, right? It can't be an acid because there's no acid word. It's molecular. We've got phosphorus. If we find phosphorus on the periodic table, that's a nonmetal. You can usually tell just by looking at the first element. The other giveaway is this prefix, penta. We can only use those with the molecular compounds. So then what's the formula for this compound? PCl5. Penta means 5. So there's 1 phosphorus and 5 chlorines. They're asking for the mass in grams of 2.48 moles. So they're giving us moles, and they're asking for grams. Relationship between grams and moles. This is the molar mass of this compound. We find the mass of 1 mole of this by taking the mass of 1 mole of phosphorus and 5 moles of chlorine and adding them up. 1 mole of phosphorus is 30.97 grams. And then we have 5 moles of chlorine, and they're 35.45 grams each. And so let's see what that adds up to. $208.22 is what the calculator says. So that equals 1 mole for this compound. I looked at the number of phosphorus atoms. There was 1. And so I took 1, which I didn't write because I'm a chemist and I don't like to write the number 1. And I multiplied that by the mass of 1 mole of phosphorus. There are 5 chlorines in this formula. So I've got 5 times the mass of a mole of chlorine. And I add those things up and I get the total mass of 1 mole of phosphorus pentachloride. That's my conversion factor. So then I use this 2.48 moles, and I'm going to multiply by grams and divide by moles. Why not multiply by moles and divide by grams? We need to find the grams, and we need to get rid of the unit mole. It's the units. So the moles cancel out. This is the relationship, grams and moles. 1 mole is this many grams. 1 mole, 208.22 grams. We'll do the mass, and how many sig figs should this have? 3. So that's going to be 516 grams. Any questions? Yes?
How come we don't do the 6.022?
Why didn't we use Avogadro's number in here? Because we had grams and moles. We weren't being asked for numbers of particles.
Okay.
Yeah.
Ask for atoms.
If it asks for atoms, then we're going to use that. And so what we'll find is that we're going to use Avogadro's number in this chapter, just so that you have an idea of it and how to deal with it. We actually don't use Avogadro's number that much in the rest of chemistry, because the mole is a much more useful unit, and that is related to numbers of particles, and that's what we really need, is something that relates to numbers of particles. This is a much more manageable size. It's actually a mass that we could weigh out and deal with in the lab. Now here's a question where we may need to use Avogadro's number. What's the mass of 8.11 times 10 to the 24th SO2 molecules? Here we're dealing with a number of particles, not moles of them, not chemist's dozen, but actual numbers of particles. And this is why I think MOL as an abbreviation for mole is so stupid. Look at this long word. There's no abbreviation for that. We can't use MOL or even MOLE because that's already taken. So we're just stuck with writing out molecule. So here we're going from molecules, and we're trying to find mass. Gram is our unit of mass. So let's write down what we know to see if we need to go to moles in between, or if we can do this in one step. So we could calculate the molar mass. We're going to need something with mass for SO2. So we're going to have to calculate the molar mass of SO2. So we've got 1 mole of sulfur is 32.07 grams, and 2 moles of oxygen. Those are each 16 grams. 64.07. Equals 1 mole. How many molecules is that? 6.02 times 10 to the 23rd molecules. Stupid long word. This mass in grams is equal to 1 mole. That's what the molar mass means. And then we also wrote down what mole means. That's kind of an ugly looking. Dot there, period. That's better. So here we have the relationship directly between grams and numbers of molecules. So we can do this in one step. One step's always better than 2. So 8.11 times 10 to the 24th molecules. We're going to multiply. What are we multiplying by? What unit? What's our path? Molecules to grams. Multiply by grams, divide by molecules. So the molecules cancel out. We put the units in first because they tell us what we're supposed to multiply and divide by. Then we look at what we've written down here. 64.02 is with the gram. It has to stay with the gram. 64.02 grams. Avogadro's number is with molecules. And then we get out our calculator. 8.11 EE 24 times 64.02 divided by 6.022 EE 23 equals, and this is another one that ends up with 3 sig figs. And so this comes out to be 862 grams. Pardon me? Did you get a different number?
No, you're saying 0.02, but it's 0.07.
Oh, is it 0.07?
32.02.
That's a 7. It may look like a 2, but it's actually a 7. Is that better? Any questions? Yes? I just lost it. Let me look. I have to calculate it again. Oh, I see what you're talking about with the 7. I'm sorry. It's this one right here. This is a 7. That's what you meant, isn't it? He's not paying attention anymore. That's fine. It's okay. Okay. Times 64.07 divided by 6.022. I can be a little dense sometimes. Yeah, when I do it that way, I get a slightly different number. 862.8. And so yes, that rounds up to 863. I misread my own writing. 7s and 2s can look a lot alike. And I don't know why I stopped doing this, but I always used to cross my 7s. I need to start doing that again. Because then you know it's not a 2. Good question. Anybody else? Did I screw up on anything else? Because that's at least two, I think three really good on YouTube screw ups today.